Welcome back to the Pressure Vessels Part 1 online course. You are now watching the introductory video of Module 1, Getting Started. This video is a quick overview of the different contents you have to get acquainted with prior any development. This is a problem-based training course. Contents are simulated through the development of real cases and design processes. In this first module, Getting Started, you will acquire all the knowledge required to get ready for the next stage, putting your hands on the calculation case studies. The contents that will be covered in this module have been outlined to acquire a solid background of general vocabulary and terminology. The contents covered in this module are design codes, mainly regarding the ASME Boiler and Pressure Vessel Code, Section 8, Division 1, design conditions, material selection, and joint efficiency. The purpose of using design codes is to avoid disasters that can affect humans. Therefore, they comprise a range of experiences and good practices. Different pressure vessel design codes can arrive at different resulting wall thickness, yet having equivalent degrees of reliability. Provisions of a design code are an interrelated set of design, fabrication, inspection, and testing requirements. For example, the use of a higher design stress might depend upon use of a stringent material, analysis, examination, and testing requirements. The ASME Boiler and Pressure Vessels Code is a set of standards, specifications, and design rules based on many years of experience, all applied to the design, fabrication, installation, inspection, and certification of pressure vessels. Some of them are construction codes, such as sections 1, 3, 4, 8, 10, and 12. Some others reference codes, such as sections 2, 5, and 9. And some others rules for operating, inspection, and in-service maintenance, such as sections 6 and 7. In this course, we will focus on ASME Code Section 8 Division 1. The organization of the code follows the structure shown in the next slide. It has three main subsections. Subsection A, General Requirements, where the most used part within this section is Part UG, General Requirements for all construction methods and all materials. Then we have subsection B, Fabrication Requirements. In this case, the most used part within this section is Part UW, Requirement for pressure vessels manufactured by welding. Then there is subsection C, Material Requirements, where the most used part within this section is Part UCS, Requirement for pressure vessels constructed out of carbon steel and low alloy steel. And finally, we have the appendices, mandatory and non-mandatory. The adequate definition of the design condition is the stepping stone of any satisfactory design. In some cases, the real difficulty of the calculation process lies with definition of the design conditions. Pressure and temperature are just two of the many design constraints that should be taken into account. Some of them are temperature, as in ambient temperature, MDMT, design temperature, pressure, operating, design, MAUP, test pressure, loading, dead loads, live loads, cyclic loading, corrosion allowance or liquid level, wind and seismic conditions, steam out, hydrostatic test requirements, transportation, and lifting conditions. Material selection and pressure vessel design depend on these design conditions. The ASME code does not recommend or suggest any material for any particular application. The code merely states what materials are allowed and the requirements they have to comply with. In order to select an adequate material for a concrete application, the following properties shall be evaluated. allowable stress, corrosion resistance, temperature resistance, and toughness or resilience. First of all, the main mechanical properties of steel must be known. The basic mechanical properties of steel can be obtained through a typical stress-strain test. The diagram shows point A is known as yield point. If the tension load is released at any point below point A, the material returns to its initial state without any permanent deformation. When this point is exceeded, the material is no longer elastic. Releasing the load on this range leaves the specimen with the permanent or plastic deformation. Point B is known as tensile stress, and point C is known as rupture point. Interestingly enough, none of the aforementioned points is used for the design of pressure vessels. So, what is the allowable stress to be considered in our designs? Pressure vessels, among other mechanical equipment, must not work within the plastic deformation zone under any circumstances. After point A, the material has lost its initial mechanical properties permanently. Therefore, the allowable stress is always a percentage below the yield point. This percentage is the safety factor, and it defines the allowable stress. The allowable stress is established by the design code for each case, and it is selected for a given material and the design temperature. Allowable stresses for all accepted materials to be used in the design of pressure vessels according to Section 8, Division 1 are found in Table 1A of Section 2, Part D of the Boiler and Pressure Vessel Code. Pressure vessels are tailored items. They are fabricated to meet the many process requirements. In order to achieve the different shapes and geometry required, most steel pressure vessels are welded fabricated. Depending on the quality of welds, the joint efficiency will adopt different values. Joint efficiency of welds can be defined as the reliability that can be obtained from them. This coefficient adopts values smaller than 1, and it can be said that the joint efficiency is a way of reducing the allowable stress of the material. Therefore, the joint efficiency depends on the level of non-destructive examination and the category and type of the weld used for joining two pieces of equipment. This video is just a quick overview of the different contents you have to get acquainted with. You should check and understand the different contents mentioned in this video in the study notes prior any development. Remember that all concepts dealt with are complementary and that assignments are linked. Keep up with the woodwork and come back for more. Thank you and have a great day.